7, Palindrome Permutation II. So we are giving a string S, and we want to return all the palindromic permutations without duplicates of it. So we need to avoid the duplicates. So for this example, so this S is a palindrome, and we find all the palindrome permutations. It is AB, BA, BA, AB. And you may return the answer in any order. If S has no palindromic permutation, we're gonna return an empty list. So that's gonna be the example 2. So this is not it has no permutation palindrome, so it's gonna return an empty array, and the length is 16. Yeah, so according to this example, we should know about it. We can use backtracking. But for 16, the backtracking is still a big number. So for example, 16 times factorial of 15, it's gonna be a really big number. Yeah, normally it's gonna be more than 2 to the power of 32. It's gonna have time limit exceeded. Yeah, can we let this number become smaller? As it is a palindrome, maybe we can use a half of the string. If the maximum it is 16, maybe we only need to use 8 times factorial of 8. So this number is gonna be a really small number. So this means the backtracking works if we can turn it into half of the problem. Yeah, because for a palindrome, as we know that AB and BA. So if we can find a permutation, if it is a palindrome, definitely, if this is a palindrome, if we find half of them, for example AB or BA, definitely we can get another half because it is a palindrome. Yeah. Now the problem becomes, first of all, we're gonna check if it is a palindrome or not. So for this S, if it is a palindrome, if it is not a palindrome, we're gonna return an empty array. Otherwise, we're gonna check if it is an odd or even palindrome. So if it is an even palindrome, we can directly do it like this. We can permutate AB with AB and BA, and then we can get another part. But if it is odd, so we're gonna take out this character, like for example this character C, and then we're gonna do it similarly like the even case. So we're gonna permutate AB and find all combinations plus a C and plus another part. So now the problem becomes how can we find the permutation of a string? If we do not use the permutations inside the Python library, we can directly define a backtrack. Yeah, because normally we should write the backtracking function. Otherwise, there's no meaning to do the problem. If you use the permutations directly, there's no meaning to do the problem because basically it's a backtracking problem. Yeah, so we should avoid using the library because there's no point if you just use permutations, you just solve the problem. You don't need to do anything about it. Yeah, basically, so I think we need to write a backtracking function to realize this permutation. So I'm gonna prepare a string A. So A is a string. So A is half of the string. So let me maybe use a half. Yeah, so this is a half of the string. And then inside I'm gonna use an answer. So I want to check the answer. It's the length of the answer equal to n divided by 2. So I'm gonna define the variable n. It's gonna be length of the string. Yeah, so I get half of them. If I can find half of them, yeah. So basically from here for the backtracking, I think the this string is a valid palindromic permutation. So it is valid. It must. So for this string, we can find some permutations. Yeah, it's not like ABC. It must be valid. We can find some permutations. Yeah. So if it is a half of them, yeah, let me just finish the backtracking function from here. So basically I want to get something inside of the result array, similarly like this. Maybe just I get a B and BA. Yeah, I just get half of them. Now I'm gonna call the backtracking function. So inside it's gonna be it's gonna be half of the string. Yeah, it may be some string, and then I'm gonna have an answer. So the answer is gonna be an empty string. So here it's gonna be half string. Let me define it as a half string. So it's gonna be like this. I'm going to prepare this half string later because basically we're going to use the hash table to solve the half string. Yeah, but let's focus on the backtracking function. This is not so difficult. So if we find it, so the result should append this answer, and we're going to have a return. Then we're going to find all the different cases. So for I in range length of the half string. Yeah, so we're gonna check all different cases. Basically, it is a backtracking. Yeah, but we need to take care of the duplicate. We should solve it without duplicate, otherwise it will have problem. For example, if AA, if there are four A's, for example, it's gonna have a duplicate. We need to avoid such cases. But how can we avoid it? First of all, we're gonna sort the string like AA. So yeah, we're gonna sort it, and then we're gonna have a tag. So it's gonna be sorted in increasing order. So for example, it's gonna be AA or AA and B, and in this way we can avoid the duplicate. So after sorting from here, we're gonna have a tag. So if I more than 0 and half I equal to the previous one, half I minus 1. So we're going to have a continue. So in this way, we can avoid the duplicate. Yeah. So if there are duplicate characters, basically we can use this formula to avoid the duplicate. And then we can go for the backtracking. So for the backtracking, we're going to take out the character from index I. So it's going to be half to I plus half I plus 1. So we're going to take out the half I and put it inside the answer. So the answer should plus half I. Yeah. So this is going to be the backtracking function. As you can see, it is not so difficult. Basically, this is just a template for solving the permutation problems. This is just to avoid the duplicate in this line. Yeah. Now we're going to focus on how can we find this half string. If we can find it, definitely we can solve it. Yeah. Now we're going to prepare a counter. So this counter gonna just count the string s. So we're gonna count it and then we're gonna check it. So for kv, k is a character, yeah, or cv. So for cv in d.i terms, and we're gonna check it. First of all, I'm gonna use a counter. So this count is to check if it is valid or not. So if this count is more than, this count is just to check the odd characters. So if some character, for example, if this is odd, B is odd, A is odd, and C is odd, definitely it's gonna be wrong. Yeah. So I'm gonna check this way. If v modular 2, this means the number is odd. Yeah. So if it is equal to 1, it is odd. So the count should plus equal to 1. So if this count is more than 1, it means definitely it is invalid. So I'm gonna return an empty array. Otherwise, I think this is gonna be invalid. Yeah, so if it is valid, I'm gonna prepare the half string. So the half string, I'm gonna prepare a half string as empty from the beginning. Yeah, now I can get the half string directly. So the half string would plus equal to, first of all, what is my character? Character is C, and how many of them? I'm gonna take half of them, so times this v divided by 2. Yeah. Now I got half of them, yeah. But I need still to get the this unique or this odd character. It is C. I need still to find this character C, because if the length of n is odd, I still need to find it. But how can we find this character? So if the palindrome is odd, so I can check it from here. Let me prepare a made, because I'm gonna put it in the middle. So I'm gonna prepare a made string as well. So the made string is, so if this is odd, so I'm gonna have my made string. It must be equal to the character C. Yeah. Now, if it is invalid, I'm gonna return an empty array. Otherwise, definitely, if it is odd, I'm gonna have an odd character made string with character C, or I will not have it, and maybe it is just even. Yeah, maybe it is even. I just need this half string. Yeah, but basically from here, I get my result. after the backtracking function, I got the result. Yeah, if everything's okay. Yeah, if you don't believe it, let's just have a check. Yeah, let's just check this half string. So for example, this half string equal to AB. Let's check what is the result. Let's just check the backtracking function. Yeah, if the backtracking function is wrong, definitely we cannot do anything. Yeah, let's just check this backtracking function first. I'm going to return something with an empty array, because I want to print out this result. I just wanted to check if my backtracking function works or not. Otherwise, there's no meaning to do these areas. Yeah. Now let's just check the backtracking. As you can see, for AB, the backtracking is AB and BA. It seems it is okay. Maybe I want to check AAA. Let me check if there's a duplicate or not. So the result is yeah. So if AAA, so the result is AA. Is that right? Yeah, if my half string is AA, 3 A's, definitely the result should be with 3 A's, not 2 A's, I believe. Yeah, if I get 2A, yeah, so this means the yeah, I cannot check it. Basically, I cannot check it like that, because this is the length of the n. I have to check it like the example 1, because I used this n. So I have to check the length gonna be 2. It should be okay. I cannot check it to 3, because let me check if it is equal to 2. As you can see, it is AA. It should be okay. Why? Because I used this n. N is the length of the example 1. It is the length of 4. So I have to use the testing cases of less 2. I cannot use less 3. So, but basically this means my backtracking function is totally right. Yeah, I just need to have a check. Now I'm gonna focus on this half string. So from here, so if the string is odd, basically I got a mid string. Otherwise, I got this half string. Yeah, and now I can get the result. I need to check if if it is odd or even. Yeah, so I'm gonna check this count. Basically, the count can only be 0 or 1. So if count equal to 0, basically this means the string must be even. So if it is even, I can directly get the result. So the result would be item plus a reverse item, and this item should be inside the result. Yeah, so this is one of the possible results. Otherwise, it's gonna be odd. So the result would be similarly. I just need to copy this result, and in the middle, I need to plus mid string. This is what I've calculated before. Before here, I've calculated this mid string, and finally, I just need to return this result. Yeah, as you can see, there's a lot of coding, but it is not so difficult. I mean, if you are familiar with the permutations of this backtracking, and if you are familiar, yeah, this is not so difficult. This is just a hash table. We just need to check if it is valid or not. If it's valid, we just need to check if it is even or odd for the string. Yeah, now let me run it to check. I need to delete S. Yeah, as you can see, basically all the testing cases works. It seems it should be okay. Now let me submit it to check if it can pass all the testing cases. As you can see, it's pretty fast and passed all the testing cases. Now let's analyze a little bit about the time complexity. And basically, it's gonna focus on this backtracking area. And this backtracking, as I explained earlier, it's gonna be 8 times 8 factorial. So this is for the backtracking. And another one is for the hash table part. So for the hash table, basically I think it's gonna be O(n) time. Yeah, because basically we didn't do anything for the backtracking for the hash table. So we just have a counter. So it's gonna be O(n). N is the length of the string. Yeah. So for here we just use the one backtracking to get the result. So the time complexity gonna be half of the string n. It's gonna be 8 times 8 factorial. So it should be okay. Yes. Thank you for watching. See you next time.